There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the moon is made up of layers: a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface. Massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the Sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the Sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. and it doesn't make any sense because it's farther away from the sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to higher-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist. Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve: what caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Our moon exploration project started out in 1969. Sure, there have been some problems along the way, but astronomers are certain we'll get back up there pretty soon and with better knowledge and technology. However, there's an 800-year-old trick that might become way more useful than fancy GPS tech and powerful rockets. It's called the Fibonacci sphere. Some scientists at a Hungarian university stumbled upon this idea while studying the moon. They believe it might be useful to better understand how the moon spins and how it's a bit squished while it goes around Earth. You might believe that our planet and its satellite are these perfect little spheres floating in space. Well, that's not true. They are in fact like slightly deflated soccer balls because of all the gravity, rotating movements, and tides. The GPS technology we use here on Earth is already adapted to these less than perfect ball proportions. Remember, our planet is a bit flattened at its poles. If we're going to make a map system for the moon, we need to do the same for its shape, called a solenoid, or what scientists call the moon's version of our Earth's shape. Since the moon is less compressed than our planet, scientists have been taking a shortcut until now. They've been looking at our satellite as a simple ball shape. However, with all these new projects coming up in the following decades and even some exciting trips we might end up having on the moon, we need to be more precise. Scientists now believe we should get the real data and start drawing an accurate picture of the moon. Here's where the Fibonacci sphere comes in handy. It's a clever solution that's been used by mathematicians to spread points out evenly on a ball, Scientists recently used it to map around 100,000 spots on the moon using data previously collected by NASA. And what they found was crucial for our understanding of the moon's shape. For instance, we now know that our satellite's poles are about 0.3 miles closer to the center compared to the moon's equator. Sure, it might seem like a tiny detail, but if we adjust our GPS software accordingly before we land on the moon again, it might save us from getting lost up there. This level of math hasn't been done since the 60s for the moon, but we already know it works wonders here at home, so it only makes scientists better prepared for future missions. This isn't the first time people have used Fibonacci's findings to come up with clever solutions. We've also seen it put to work in finance, agriculture, and in computer science. Let's see where it all came from. Legend has it that the Italian mathematician Fibonacci wasn't really that interested in mathematical sequences at first, but rather in rabbits? So, he came up with this interesting puzzle. What happens if you place a pair of rabbits in a certain space for a year? He also set some theoretical rules. For starters, all those bunnies come in boy-girl pairs, and they can start reproducing after just a month. Each month, each bunny pair adds one more pair of bunny offspring. The last rule was that all bunnies would be invincible for the year. Doing the math, he got this series of numbers. 1, 1, 2, 3, 5, 8, and so on. If you look at this series again, you'll notice that every number is the sum of the two before it. The first two, that's your starting bunny pair. Next, you'll see the number 2, which is the first pair and their first offspring pair. Word caught on about this interesting sequence, and math lovers began studying it more closely. They started seeing this pattern very often in nature, like in how leaves grow on a plant or how seeds arrange on sunflowers. There's even a little experiment you can do to check it out. Start by grabbing some paper and a pen. Try drawing the Fibonacci spiral. Start with a tiny circle, then go bigger and bigger using those Fibonacci numbers. The first circle should just be a tiny dot on the paper, or the equivalent of 0. Next circle, 1 unit. Another circle, still 1 unit. Keep it going and you'll see that the circles form this spiral pattern. Even as it continues to grow, it keeps its shape. You might have also stumbled upon the Fibonacci spiral as a symbol of hypnosis. In all fairness, there's little evidence you can confuse someone by making them stare into a spiral for a while. But its effects on our focus and our optic nerves can't be ignored. After you've stared at a spinning spiral, you might see how objects get smaller or bigger depending on the direction of the swirl. It's easy to understand why some experience this sensation as hypnotizing. This interesting series of numbers appears in our day-to-day lives, even if we don't notice it. It can also be used in more practical instances, like converting miles to kilometers. Let's look at the series 1, 2, 3, 5, 8, 13. Pick any two numbers side by side. Say 13 and 21. Do the calculations and you'll notice that 13 miles is about 21 kilometers. Same with 34 and 55. Music and math might not seem like they're connected. But if you had asked the great Mozart, he probably wouldn't have agreed. It seems he was very passionate about numbers from early on in his career. He loved finding cool number patterns in music, like some sort of hidden messages. His own sister even remembered him doodling math all the time, even on the sides of his music sheets. Some scholars believe he might have even played around with the Fibonacci numbers. If that's really the case, then he might have used the ration to balance out parts of his tunes. What about other types of art? Well, it's also said that Leonardo da Vinci used the golden ratio in his masterpieces, like the Vitruvian Man and the Mona Lisa. Also, when it comes to great pieces of architecture, the Parthenon might have used this pattern too. Anytime you see buildings with columns spaced just right, you can be certain that's where the builders drew inspiration from. The Great Pyramid of Giza is another great example. There's no official record to prove it, but the pyramid's shape is so close to the golden ratio that it's kind of obvious. You'll also see this pattern appearing naturally in our environment. Go out in our garden and check to see if you have any pine cones lying around. See those scales? They're set up in a pattern according to the Fibonacci sphere. Even the bones in our body seem to be growing based on the same proportions. We've got one torso, one head, and one heart. Then there's stuff that comes in pairs. Our arms, legs, eyes, and ears, for instance. For the number 3, think about the composition of our limbs and the 3 main sections in our hand. The wrist part, the middle palm part, and our fingers, which are also split into 3, by the way. Oh, speaking of fingers, their bone lengths have this ratio too. This design helps our fingers move smoothly, especially when grabbing objects. The Fibonacci sequence can be seen in the way ocean waves curve, and how rivers split and flow too. Weather patterns can also follow this rule. Some whirlpools and hurricanes form and spread out in the same way the Fibonacci spiral does. Zoom out, and you'll see that spirals aren't just found here on Earth. They're also everywhere in space, and it isn't random. Most galaxies, including our Milky Way, are spirals. Think of it like this. Generally, stars in a young galaxy don't all appear at once. Some are faster when developing, others take their time. This makes gravity pull in different ways, making the young galaxy spin like a disk. As it spins, different levels of gravity stretch it into getting these spiral arms. On the flip side, if all the stars in a young galaxy appear at the same time, gravity just smushes it all into an egg shape, or what the astronomers call elliptical.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of 2 very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Haitian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live, but it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years, and even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggest it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler-186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler-186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it Exo-Venus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable.
Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago. But they appear much younger than expected. Typically found in clusters of 10 to 40. They're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger, and the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the moon. In its early years, the moon was just a molten world, shaking from intense volcanic and seismic activity. So, the moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out, 4.43 billion years ago. This was a huge turning point, not just for the moon, but for Earth too. After all, the giant impact that formed the moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The moon gradually cooled and contracted. And now look at this modern-day rocky sphere illuminating our nights. But the moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the moon's continued activity. As it cools, the moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria. See these large, dark patches on the moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the moon actually affect humans? In a sense, it can. The moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, there's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the moon's surface, grinding much of it into powder. Unlike Earth, the moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, constant exposure to solar wind has given the regolith an electrostatic charge, making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term moon missions much cheaper and more practical, helping astronauts live and work on the moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus,
this ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains in Cetulus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that. This planet, yeah, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, It attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. Ooh. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Baekdu was once 2 stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the 2 stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super-Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP-107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system.
It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions. But they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project: figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000 from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must, That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
There are a few theories about how the moon appeared in the sky, and recently a new idea has popped up. But before we discuss this newcomer, let's look at the most popular hypotheses of the moon's formation. The capture theory claims that Earth's natural satellite used to be a wandering body, something like a large asteroid. It had formed somewhere else in the solar system before it was captured by our planet's gravity when passing nearby. The accretion hypothesis suggests that the moon formed in orbit around Earth at the same time as our planet appeared in the darkness of the cosmos. Then, there's the fission theory that says that at one point in its development, Earth was spinning so fast that some of its material broke away and started to orbit the planet. And the giant impact theory, which is the most popular these days, claims that the moon formed during a collision between Earth and another hypothetical planet called Theia, which was way smaller, probably the size of Mars. The resulting debris collected in an orbit around Earth and formed the moon. And now, let's move to the new theory you've been patiently waiting for. According to it, our satellite might have formed immediately, in a matter of hours, after the collision between Earth and Theia. The material from the two planets was likely launched directly into Earth's orbit right after the impact. It formed the moon and left traces deep inside Earth. In previous scenarios, Theia's remains were thought to have been scattered all over space, mixing with just a bit of the material coming from our own planet. But then, why do we see such shocking similarities between the moon's and Earth's compositions? Could it be that Theia was isotonically and chemically similar to Earth? Unlikely. But according to the new theory, more material from Earth was used to create the moon, its outer layers in particular. It might explain this similarity in composition. One more theory also tries to explain this mysterious similarity, the synestia model. According to it, our satellite formed inside a swirl of vaporized rock left by the collision. But this theory can't explain the moon's current orbit. The new single-stage theory does offer us plausible explanations for both the similarities in composition and the orbit of the moon. It might also provide us with some answers to previously unsolved mysteries. Since this scenario puts the moon into a wider orbit and gives it an interior that is not fully molten, it can explain the satellite's tilted orbit and thin crust. In any case, to confirm one of these theories, we need to analyze future lunar samples that will be brought to Earth by NASA's upcoming Artemis missions. Scientists will be able to get their hands on some material from deeper beneath the moon's surface and compare if real data matches these simulated scenarios. In the past, the Apollo missions already brought back about 1/3 of a ton of rock and soil from our satellite. These samples showed that Earth and the Moon had some remarkable chemical similarities. They could only suggest one thing. These space objects had a linked history. If the Moon had formed elsewhere and been captured by our planet's gravity later on, its composition would be very different from that of Earth. But if the Moon had been created at the same time as Earth, or if it had broken off our planet, the type and proportion of minerals on the Moon would be the same as on Earth. But they are a bit different. The Moon's minerals contain less water than their terrestrial counterparts. The satellite is also richer in materials that form rapidly at high temperatures. That's why the most accepted model of the Moon's formation these days is the giant impact model. Meteorites coming from the Moon are a great source of data for studying the origins of our satellite, too. They can tell us even more about the Moon than Apollo samples, all because such meteorites come from all over the surface of the Moon. Meanwhile, Apollo samples were collected just in one place near the equator, on the near side of the Moon.
Technological progress does not stand still, and over the past decade, the resolution of images of the lunar surface has improved greatly. Many pits have been discovered on the surface, and some of them are really impressive in size. The largest are hundreds of feet deep. However, technology is not yet advanced enough for us to study the bottom of such pits in detail. That's why a recent discovery is surprising. It turns out that huge pits can extend deep into the rock of the Moon. It's a groundbreaking discovery. Let's figure out why. So look at this giant underground cave. Leonardo Carrere and Lorenzo Bruzone from the University of Trento were thrilled to finally confirm the existence of such structures on the Moon. They analyzed images taken by the mini RF instrument on board the Lunar Reconnaissance Orbiter in 2010. The original images didn't have excellent resolution, so the authors had to do a huge amount of work, using modern data analysis and modeling techniques. But first things first, why does it all matter so much? Well, instead of building homes on the surface of the Moon, we might be able to live inside these natural caves. They could offer protection from dangerous things like harmful space radiation, extreme temperature swings, and even meteorites. According to planetary geologist Wes Patterson from Johns Hopkins, even though we'd still have to bring materials from Earth to make those caves habitable, using them would be a lot easier and cheaper than building bases on the surface. Based on the collected data, the cave is about 150 feet wide and up to 260 feet long, which is just a bit smaller than a football field. It's located in a deep pit called the Mare Tranquillitatis Pit, which likely formed when an ancient lava tube collapsed. Although the Moon has no active volcanoes today, billions of years ago, its surface was covered with lava that flowed through valleys, carving out these tubes below the surface. Over time, some of the lava tubes became unstable and collapsed, creating pits like the one in question. NASA's Lunar Reconnaissance Orbiter, LRO, has already found more than 200 of such pits on the Moon. It means there could be hundreds of hidden caves waiting to be explored on our satellite. When publishing their findings in Nature Astronomy, the researchers suggested that the caves could offer future astronauts a safe place to live and work, protecting them from the Moon's extreme conditions. And extreme they are. One of the biggest challenges of living on the Moon is its temperatures. The lunar surface gets extremely hot during the day, reaching about 250 degrees Fahrenheit, and then the temperature drops below minus 200 degrees Fahrenheit at night. But inside the caves, the temperature could stay much more consistent. A separate study done in 2022 used computer simulations to predict that some of those caves could maintain a comfortable temperature of about 63 degrees Fahrenheit. Much easier to manage, right? Unfortunately, getting to the caves won't be easy. The Mare Tranquillitatis Cave is over 400 feet below the surface, at the bottom of a steep slope covered in loose debris. It would take some clever engineering to get up and down that slope. The options could be using jetpacks, a lunar elevator, or some other kind of technology. We must find a way to transport astronauts safely. There's also a lot more to discover. Radar technology could help scientists find even more caves and lava tubes on the Moon. In the future, a spacecraft with higher resolution radar could even map the insides of the pits that LRO has already found. According to the researchers, this kind of complete survey could help them figure out the best locations for future lunar bases and other explorations. And there's another potential bonus. Those caves could contain water. Scientists have already found frozen water on the moon, under the surface, and in permanently shadowed craters. Tiny amounts are also scattered across the lunar dirt. Water is a critical resource for any moon base, and finding it in the caves could make the idea of living there even more realistic. All in all, this discovery could be a game changer for lunar exploration. Living in natural caves on the moon might be a more practical and safer option than building something on the surface. It could also bring us one step closer to making the moon a place where humans can live and work for the long term.
Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4 billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the Moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the Moon before, it was the first time a rock from the Moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the Moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the Moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the Moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the Moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the Moon's formation around 4.5 billion years ago. On the far side of the Moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory Mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the Moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the Moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the Moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts. About 8 billion inhabitants of planet Earth found out the same terrible news in one day. Someone saw it on TV. Others heard it on the phone while scrolling through social media or listening to music. Some witnessed this news in a dream while sleeping. Someone's voice said it in all languages to ensure everyone understood it. I have good news and bad news for you. Let's start with the bad news. You're all characters in YouTube videos in which your planet gets into a situation where the moon breaks in half. For the audience, it will be a hypothetical story, but for you, these events will become a reality. The good news is that I was joking. There's no good news. But don't worry, the apocalypse won't start on your planet. Maybe just a little bit. Have a nice day. At first, the entire population panics. Then, a few days later, everyone calms down. Maybe it was a mass hallucination, and the moon will be all right. But at this moment, scientists have discovered the danger. A colossal meteorite is flying towards us from the distant depths of space. This meteorite is super fast and pretty flat, but has sharp edges. Fortunately, it will miss the Earth by a few thousand miles, but the moon won't be that lucky. The meteorite flies through our Earth's only natural satellite directly in the middle. So it passes through the moon, sweeps past our planet, and flies away into distant space. At this moment, all people can't take their eyes off the moon. The meteorite cuts it perfectly in half, gently, clearly, painlessly. So, what shall we do now? Will the Earth survive this? Our satellite breaks into 2 equal parts, but fortunately, they don't fly away from each other. The moon's great gravity attracts them back like a magnet. Scientists are sure that the parts will connect in a couple of billion years, and the moon will become the same as it used to be. But the coolest thing is that people won't feel any changes. Everyone around the world will celebrate this good news. The voice was wrong. But then, another problem appears. A massive meteorite in the form of a shoe is flying from the deepest space to us. It enters our solar system and approaches the Earth at high speed. The space boot crashes into one half of the moon and then flies away. Now, the moon is definitely breaking into 2 parts. The first half remains in the same place. The second one is flying towards us. A small meteor shower begins on Earth because of the falling moon fragments, but it's not so bad. Most of these rocks are burning up in the atmosphere. But almost the entire split-off half is falling apart around the orbit of our planet. It forms a stone belt. Now the Earth is like Saturn. Rotating fragments destroy part of our artificial satellites. Communication and the internet work inconsistently. It takes people a couple of years to restore a stable connection. The International Space Station no longer exists. Luckily, all the astronauts managed to return to Earth before half the moon got to them. So, moon rocks are flying around the planet, and people see half the moon in the sky. Life doesn't change much for the first few days, but those who live on the coast of the seas and oceans notice the consequences. The moon used to influence the tides. It was flying around the Earth and made oceans take an oval shape. There were tides on the side where the moon was closer. There were ebbs on the opposite side. But now, this schedule is wrong. Half of the moon attracts less water. Yes, the moon lost half its weight and began approaching the Earth. But its gravitational force has become weaker. Seabirds, many species of fish, sea turtles, and other coastal animals may not survive these changes. Their natural instincts associated with the moon help them determine the time for getting food, breeding, and flying south. For example, tiny turtles expect a strong tide in the morning. They run to the water, but the water doesn't reach them. Turtles can't hide in the ocean in time and become dinner for seagulls. Crabs can't lay eggs because the tide has started earlier than usual. Wolves go mad in the woods. They howl loudly every night and can't stop. The whole natural world can't understand what's going on. The human body is also feeling some discomfort. Many people have low and high blood pressure, and some experience severe headaches. Half of the moon changes the entire ecosystem of the planet. Adapting to new conditions will take several tens, maybe hundreds of years. A couple of weeks pass, and people notice the days are now shorter. The moon always slowed the Earth's rotation and made one day last 24 hours. The Earth is spinning faster now. The night and the morning come earlier than everyone is used to. Earth rotation speed has increased and reduced the number of hours per day to 15. People suffer from insomnia or oversleeping. The body needs time to get used to it. Work schedules are changing all over the world. Previously, people came to the office at 9 and left at 6. Now, they arrive at 7 and leave at 2 p.m. Sleep time got shorter, and people are really sad because of this. Progress slows down because the short working time. The technologies of the future are now 20 to 30 years late. Hourly pay remains the same, so bosses now pay less for fewer working hours. The whole moon stabilized the weather and climate on the planet. Look at Mars. It has 2 small moons. They quickly spin around it and rock Mars around on its axis. As a result, strong winds, sandstorms, and thunderstorms often happen on the red planet. Now the half of the moon that approached us takes the Earth out of stable rotation. This changes the seasonal temperatures in the world. It even gets hotter in hot places. And snowstorms are raging in cold regions. There are short, massive downpours instead of sunny weather. A typical breeze can grow into a hurricane and small waves into a tsunami. The seasons are changing faster now. Winters are colder and summers are hotter. Changing the rotation of the planet affects the Earth's magnetic field. Since the compass and navigation systems are unstable now, we need to recalculate where the north and south are. Birds can't fly south to wait out the winter since they don't know what direction to fly. Their inner compass is broken. Several hundred years have passed. People are entirely accustomed to the new conditions on Earth. New species of animals and fish have appeared. Birds can navigate the sky by the moon again. The planet's economy has been restored. Hourly wages have become higher. People now get enough sleep from 5 to 6 hours a day and work for 4 to 5 hours. The reduction of day and night has also affected the entertainment industry. Movies now last 1 hour. One episode of some TV series lasts 30 minutes. Life goes faster. An average person now lives to be 96 years old. In fact, the passage of time hasn't changed at all. Its calculus did. Several thousand years have passed. People look different now. Now they have big eyes that absorb more light. Half of the moon doesn't shine as bright as the whole thing, so the nights have become darker. It took the human eye a couple of thousand years to develop the ability to see clearly in this new dark. Animals need to navigate better in these conditions, so their eyes have become larger and more sensitive. During all this time, people have cleared the orbit of moon rocks. Several space stations fly around our planet. And again, people hear this strange voice that once told them that they were all characters in one hypothetical YouTube video. This time, the voice says, "Your story ends because the video ends. I'm sorry. Good night."
TRES 2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here, it's pitch dark and scorching hot. TRES 2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first, because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189377b oh, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular, it's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Karat XO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. We're used to thinking that asteroids are the only free-floating rocks in space, but things like OTS-44 make you think twice and shiver. Imagine a planet about 11 times more massive than Jupiter roaming in space without being bound to the orbit of any star. Given its gargantuan size and mass, if OTS-44 collides with any other planet, it would utterly destroy it and go on floating as if nothing happened. Scarier still, scientists are sure there are millions of such rogue planets out there, just waiting to be discovered. There's no hard proof of their existence yet, but theoretically, carbon planets have formed somewhere closer to the center of our galaxy. Any oxygen getting in their atmosphere will get into a reaction with carbon and transform into CO2, forming black toxic clouds. On the ground, there would be oceans made of tar, spewing up geysers of methane and crude oil. There would be rains too, but they'd be far from refreshing. Torrents of pure gasoline and hot liquid asphalt would blast the ground and probably burst into flames on impact. Hard to imagine anything that would survive such conditions.